Hi there, in this lesson we're going to be looking at dividing polynomials, and this is really just part one of this because today we're going to do this by long division. Alright, so we're going to start off with something a little bit more on the simpler side, and that's dividing a polynomial by a monomial, so many terms by a single term. And to do this, we're essentially just going to use our distributive property, and really our distributive property applies here because division and multiplication are technically the same thing. So when we have a number being multiplied on the outside of parentheses, I multiply it by everything that's inside the parentheses. That's our distributive property for multiplication. Division's no different. If I have an entire polynomial in parentheses divided by a single term on the outside, I'm just going to divide each piece in the parentheses by that single term on the outside. Okay, so I'm going to use my distributive property. So if I look at this first one, again, I use my distributive property, so I'm going to distribute the division to each of these. Just like I would if it was multiplication, except it's not, it's division. So I would do the 9x cubed divided by the 3x squared, and I would do the 6x squared divided by the 3x squared, and I would do the 15x divided by the 3x squared. And so I just divide each piece, and as I divide the numbers. I deal with my rules of exponents. So this first one's going to give me a 3x, the next one is going to give me a minus 2, and then this last one is going to give me a 5x to the negative first, which is 5 over x. And that's it. If I look at the next one, I do the same thing. So I'm going to do my distributive property. So I'm going to distribute to each of these terms. I'm going to distribute that division. So the first one is 4a cubed divided by the 2a squared, plus the 10a squared divided by the 2a squared, and then the 3a divided by the 2a squared. And now I just use my rules of exponents and I divide some things. So this one's going to give me a 2a. This one gives me a 5. And this one gives me a 3 halves a to the negative first, which is really the same thing as 3 over 2a. And that's it. And really the idea here now is to go from this step right to this step. Just like we did with our distributive property with multiplication, we don't show that intermediate step anymore. We go right to multiplying as we distribute, and we kind of want to do the same thing with this. And it's easier when we have it in this format. This is still a division problem. Remember, a fraction bar is a division symbol. It's just a special kind of division symbol. So because it's still going to do my distributive property, I'm going to divide each of these. But this time I'm going to skip that intermediate step. So I do the 5b to the fourth divided by 5b cubed gives me a 1b to the first, so just b. And then the next one, negative 15b squared divided by 5b cubed is going to give me a negative 3b to the negative first, which is negative 3 over b. And then the last piece, 1 divided by 5b to the third, just ends up being 1 over 5b to the third. And that's it. Alright, so I just divide each piece, and I did it as I distributed this time. Sorry, I didn't like the look of that 5. There we go. Same thing with the next one. I'm going to divide each piece, so I'm doing my distributive property for each of these. So I distribute that division. When I do the 12c to the fourth divided by 6c gives me a 2c cubed. 18c squared divided by 6c gives me a plus 3c. And then the 9c divided by the 6c gives me a 3 halves. And that's it. The next thing we're going to look at is just a refresher in terms of long division when it comes to numbers, because maybe we haven't done this in 2nd grade or 3rd grade whenever you did this, or 1st grade, I don't know. I have never taught elementary school, so you did this at some point when you were little. And so long division, remember what we do is we kind of break this down and we look at one term at a time in terms of what we're dividing into. So in this first one, I just look at the 3 compared to the 4 here, and I say how many times does 3 go into 4? And 3 goes into 4 one time. So I put a 1. And now I need to multiply and find my remainder, so I do the 1 times the 3, and I subtract to give me my remainder, which is a 1. And now I bring down the next term, the 5, and now I say 3 goes into 15. Again, I'm looking down here. So 3 goes into 15 how many times? And 3 goes into 15 5 times, so I write a 5 up here. And now I multiply and subtract to find my remainder, so 5 times 3 gives me a 15, and I subtract and get a remainder of 0. Now I bring down the next term, and now I say 3 goes into 7 how many times? Well, it's twice. I multiply and subtract to find my remainder. And now I bring down the 18. I say 3 goes into 18 6 times. I multiply and I subtract to find my remainder, which is 0. So I find out that this one divides evenly. It's 1,526. And that's it. If I look at the next one, I start off doing the same thing. I say 9 goes into 1 how many times? Well, it doesn't, so it's 0. So I kind of go to the next term and say, okay, now 9 goes into 12. So I'm looking at these collectively. 9 goes into 12 how many times? And the answer is 1. And now I need to multiply and subtract to get my remainder, so I have a remainder of 3. And now I bring down the 4 and say, okay, 9 goes into 34 how many times? It's a 3. I multiply and I subtract to find my remainder. And now I bring down the 5 and I say 9 goes into 75 how many times? It's an 8. And now I multiply and subtract to find my remainder. And now I bring down the next term, which is a 2, and I divide. 9 goes into 32 how many times? It's a 3. I multiply and I subtract to find my remainder. And now from here, there are two options that we've learned previously. Option number 1 is if you want this as a decimal, you put a 0.0 here, and you put the decimal up here as well, and you start bringing down zeros, and you multiply, that's a 5, and you get a 45, and you subtract and get another 5, and then you bring down another 0, and you do it again, and you keep doing that until either the decimal ends or you find a pattern. All right, that was option 1. Option 2, which should have been the first option you learned, is instead of writing this out as a decimal, we're going to leave it as a fraction. And to do that, whatever we have here, and this kind of goes back to when we did remainders, don't write down R5 for remainder of 5. That was the first way you ever learned it. But then from there, you just take that remainder, the 5, and you put it over the thing we were dividing by, which is a 9. And so what I end up with is a mixed number, 1,383 and 5/9. And that's it. And I'm erasing instead of putting a box around this thing. Let me try again. There we go. All right, so now we're going to apply that same thing to polynomials. So when I look at dividing polynomials, a polynomial by a polynomial, I'm going to use long division, and I'm going to divide the same way I did when I was using long division with numbers. The only difference is when I look at the polynomials, I'm just going to look at the first terms when I do the division. I'm not going to ignore it the whole time, so if there's multiple terms, I'm just looking at the first terms to decide what the division is, and then I look at the entire polynomials as I multiply and subtract to get my remainder. All right, but it's the same process, so if we are good at dividing using long division with numbers, this should be fairly easy in terms of the process. So let me set it up in terms of long division. I've got the d plus 3, and I'm dividing that into a 3d squared minus 4d plus 13. And so now what I want to do is I want to divide this in, and I want to look at it this way and say, okay, d, I just look at the first terms here. So I'm just looking at the d, and I'm just looking at the 3d squared. I say d goes into 3d squared how many times? And that is a very strange question. That's a difficult question for us to answer. So let me think about something like this. On the previous page when we were doing some of the long division with numbers, at one point we had 15 divided by 3, and I asked the question, how many times did 3 go into 15? And the answer is 5. But here's another way I can ask that question. Instead of saying, how many times does 3 go into 15? I'm going to say, what times 3 will equal 15? And the answer is still 5. See, it's the same question, but I'm asking it in terms of multiplication instead of division. All right, so when I ask the question, 3 goes into 15 how many times? 5. 3 times what will give me 15? 5. It's a different way of asking the same question. In one instance, I'm asking it in terms of division. The other instance, I'm asking it in terms of multiplication. So apply that same thing here. Instead of thinking about this in terms of division, instead of saying d goes into 3d squared how many times, let's ask it in terms of multiplication. D times what will give me a 3d squared? And that's an easy question to answer. The answer is 3d. And now I do the same thing that I would normally do. I multiply. I take what's up here times what's out front, and I write it underneath here so that I can subtract and find my remainder. And just be careful. If I want to do 3d times d plus 3, I have to use my distributive property, and it gives me a 3d squared plus 9d. And now I want to subtract. And be careful when I subtract here, I'm subtracting this whole thing. So I'm doing 3d squared minus 3d squared. and then I'm doing negative 4d minus 9d. All right, and there's a lot of places to make sign errors here. My recommendation, let's change this to adding the opposite. Adding the opposite. And now let's add straight down. We can see that I get a 0 for the 3d squareds being added together. And here I get a negative 13d. All right, now just like long division, I bring down my next term, which is the plus 13, and I start the process over. D goes into negative 13d how many times? Let me rephrase that question. D times what will equal a negative 13d? And the answer is a negative 13. And now I multiply using my distributive property. And now I'm going to subtract to find my remainder. Again, I'm going to change subtraction to adding the opposite because I don't want to make a sign error. I get a 0 and then a 52. Now there's no more terms to bring down, so I stop the problem here and say 52 is my remainder. And now it's just a question of what do I do with my remainder? Well, I put it over the thing I was dividing by. I'm going to write it as a fraction. So I'm going to put a little plus sign here. And I put the 52 over the thing I was dividing by, which was the the d plus 3. And that's it. That is terrible. I just put that line right through my d. There we go. Okay. If I look at the next one, I'm going to apply the same thing. So I'm going to start off the same way. X minus 1. I'm dividing that into an x cubed minus x squared minus 2x plus 8. And so now I look at the first terms. I say x goes into x cubed how many times? If I rephrase that, it's x times what will give me an x cubed? And the answer is an x squared. And now I multiply using my distributive property. And now I'm going to subtract. Sorry, I've been doing this in red, and I want to keep doing that so we can see that subtraction, which I'm going to change to adding the opposite. I add straight down, and what happens here is I get a 0. So I get 0. I'm actually going to write it, though, as 0 x squared. Well, I guess I really don't need to write it. But really, since I get a 0 there, now I just bring down the next term. And if that 0 being in your way here, or 0x squared, if that bothers you, because we don't want to think about that thing, there's no point of trying to divide into that, so let's just get rid of it. And then what a lot of people like to do is they like to bring down all the terms, so I'll bring down the 8 as well. And now I start the process over. X goes into negative 2x how many times? Or I should say x times what will give me a negative 2x, and the answer is a negative 2. And now I multiply using my distributive property. And now I subtract, which again is the same as adding the opposite. That gives me a 6. And there's no other terms to bring down. That's my remainder, so I put a little plus sign, and I put the 6 over the thing I was dividing by, which was the x minus 1. And that's it. The place this becomes just a little bit tricky is if we're missing some terms in descending order. So here's what I want to do, just as a general rule. If we're missing terms in descending order, we have to put zeros in their place. And what that does is it lines everything up for us in terms of like terms and makes these much, much easier. And when we get to the next thing, which is synthetic division, you have to put zeros in their place. See, here is not technically necessary as long as you understand combining like terms and how that works. It just makes it much, much easier in this situation. But in the next situation we'll discuss, you have to do it. So we want to get in that habit now. So I'm going to put zeros in for missing terms. So when I look at the two things that are being divided here, on the outside I've got a 3x minus 1. That's not missing any terms in descending order. I've got an x to the first and then an x to the 0 essentially. So the 3x minus 1 is fine the way it is. Then when I look at the 18x cubed minus 8x plus 2, something's missing in descending order. I'm missing the x squared term. So what I do when I write this down, I say 18x cubed, and then I say plus 0x squared minus 8x plus 2. I put a 0 in for my missing term. And the easiest way to think of this is I like to think of it like you're saving a seat for your friend. All right? If you're at the table and you don't save a seat for your friend and that friend shows up, they're going to be pretty angry with you. And they might not want to be your friend anymore. So what you do is you save a seat for them because you think, you know what? I think my friend's going to show up and I want a place for them to sit. So that's what I'm doing here. I think my buddy x squared is going to show up at some point. So I want to make sure that I save him a seat. All right? So that's what I've done. And now I start my division process the same as I did before. Oops, let me get rid of that. So 3x goes into 18x cubed how many times? Again, 3x times what will give me the 18x cubed, and the answer is a 6x squared. And now I multiply using my distributive property, and watch what happens. I get 18x cubed minus 6x squared. My buddy x squared just showed up, so it's a good thing I saved him a seat. All right? And you can see that if I didn't have my 0x squared in here, when I go to subtract, see here when I go to subtract, it's easy. Change it to adding the opposite, and it gives me a 6x squared. But if I didn't have that 0x squared there, the 6x squared would be stacked on top of the negative 8x, and they're not like terms. Okay, I've got two people sharing one seat. They're going to have to sit on each other's laps, and that's not comfortable for anybody. All right, so we want to save that person a seat so that when he shows up, we have these things stacked properly, and we can combine like terms. And now I'm going to bring down the other terms. And now I start over. I say 3x goes into 6x squared how many times? Or 3x times what equals 6x squared? And the answer is a 2x. I multiply using my distributive property. And now I'm going to subtract, which is the same as adding the opposite. When I do that, it gives me a negative 6x plus 2. And now from here, 3x times what will give me the negative 6x? It's a minus 2. I multiply, that's a negative 6x plus 2. And now I subtract, which is the same as adding the opposite. And when I do that, I end up with a 0. And what that means, it means that there's no remainder, but more importantly than that, it means that this thing divided evenly. And so when you think about how things dividing evenly, so this is my answer. But now think about this in terms of factoring. If you look at just this original guy right here, this 18x cubed minus 8x plus 2, if I asked you to factor that, we don't really have a method for factoring that thing. I can't factor it. But through long division, we should be able to see the two factors here. If I write the factored form of this thing, if I were to factor that trinomial up there, it ends up being a 3x minus 1 times 6x squared plus 2x minus 2. See, I can see my factored form because 3x minus 1 divided evenly. It means it's a factor of that trinomial. And when I divide that 3x minus 1 out, it leaves me with my other factor. And that's what factoring really is, remember? Factoring is just dividing out. So if it divides out evenly, I can write this thing in factored form. And that's important to understand for later. Okay, so be aware that factoring is just dividing out. Long division can help us factor these trinomials that we previously didn't know how to factor. Okay? If I look at the next one, I'm not missing any terms in the y squared minus y plus 1, so I'm just going to write that guy down. And it looks like I'm not missing any terms. Well, I am missing some terms in the next one. The y to the 4th is missing the y cubed, so I'm going to put a 0. Almost forgot my 0 there. A 0y cubed, then the plus 2y squared, the minus y, and the plus 5. Okay? And let me move this thing. Let me scoot this guy down just a little bit because I have a feeling I'm going to run out of space up top. And now I go ahead and start doing long division. Y squared goes into y to the 4th, y squared times, okay, or what times y squared will give me y to the 4th. I multiply using my distributive property, that's y to the 4th, minus y cubed plus y squared. And now I subtract, which is the same as adding the opposite. Gives me y cubed plus y squared minus y and the plus 5. We're just going to tag along for the ride. Y squared goes into y cubed, y times. So y times that, I multiply out using my distributive property. And now I'm going to subtract, which once again is the same as adding the opposite. And what happens here when I add the opposite, I end up with, sorry, that should have, oh, no, that's right. So now I end up with, that's a 0. This gives me a 2y squared. That ends up being a minus 2y and a plus 5. And now I start the process over. I say this has to be a 2. I multiply using my distributive property. And now I subtract. Again, that's the same as adding the opposite. And what happens here when I subtract, it looks like I'm just left with a 3 unless I made a mistake somewhere. Let me double check it. And I don't see anything, so it looks like my remainder is just going to be the 3 over the thing I was dividing by, which is the y squared minus y plus 1. And that's it. So again, very tedious, very cumbersome in terms of these problems. Lots of places to make little sign errors. But as long as you're really careful, you go step by step and change that subtraction to adding the opposite, we should be all right. Okay?